Okay, so let's pick up with lesson 9.6. In this one, we're going to talk about the inverse trig functions. So we talk a lot in math about inverse trigs, or inverse functions, adding and subtracting, things like that, things that undo one another that have this relationship between them. So an inverse trig function, first of all, the purpose of it is whenever you have a triangle, a right triangle, as we have here on this picture on the right, you know all of the sides, okay? So we know all of these angle measurements. Now maybe I want to figure out what value is the degree that will give me a triangle that looks like that. So I know it's a right triangle. Well, it's a bad right triangle. But what must these angle measures be that give me whatever the given side lengths are? So it's the opposite. What we did last lesson was they gave us one of the angle measures, and we could fill out some portion of the triangle based on what was given. Okay, now they're going to give us the sides of the triangle. We fill in the angle measures. So hopefully that makes sense in terms of how that is the inverse, the opposite of what we were doing before. All right, we're going to come back to this little chart in a moment, but maybe this triangle is familiar to you. Look at it closely. It's a right triangle. My little leg is 1, my hypotenuse is 2, and my long leg is the square root of 3. Hopefully in your head you're thinking, oh, that's a 30, 60, 90 right triangle, and you're absolutely right. Now, but we know that obviously not every triangle has a special ratio that we have memorized. So although in this problem we can fill in the answer pretty quickly, that this is going to be a 60-degree angle, this is going to be a 30-degree angle, we couldn't always make it that obvious. The reason they do that here is just so we have something to build off of. Okay, so I'm going to erase those measurements even though we know, even though we know that's what they are. Okay, so let's look at the question, or the directions. Determine which of the two acute angles has a cosine of 0.5, or 1/2. Meaning, is it angle A or is it angle B? And when I find the cosine, I get 1/2. So I'm going to do the cosine of angle A first. Cosine, we've done a lot by this point. So ca, which is my adjacent side, square root of 3 over my hypotenuse 2. That obviously does not equal 0.5. So it's not angle A. How about the cosine of angle B? My adjacent is again so ca. Make sure you're spelling that right whenever you do it. For cosine, it's from angle B, my adjacent side is 1, and my hypotenuse is 2. And there we have it. So, going back to what we had already filled in, we can say that which of the two acute angles has a cosine of 1/2? Well, it must be angle B. Okay. Now, what there used to be that was used a lot before we had calculators, kind of in addition to a different alternative, is then you would say, okay, so the angle that has a cosine, we would look at this table that they have here, cosine of 1/2, 0.5, and that's going to carry over to what angle measure that must be. And look, we get the same answer. We already knew this was a 30, 60, 90 right triangle. That's why they worked with it. So it's something we knew. But you could use a table like this. So possibly you've seen something. I remember this being in the back of my math books growing up. We didn't use it extensively. Maybe your family that has. But again, it shows all the angles from 0 all the way up to 90 degrees, and it tells you the sine, cosine, and tangent of those. Okay, so it's a trig table. But we know that we can have an angle measure of 0.5 degrees. So it doesn't tell us everything, but it gives you good approximations, and you can do work from there and within there to get other missing pieces. But we aren't going to use those. We're going to use our calculators. Okay, so here's the inverse trig ratio. This is what it looks like. It looks like this. So the expression tan with a little -1 up top, and then x is read the inverse tangent of x. Okay, the inverse tangent of x. So you can think of it as it's the angle that has a tangent equal to x. Remember, when we do inverses, what we're trying to find, when we're using the inverse, we're trying to find an angle measure. Okay, all right. So if the tangent of A is equal to x, then the tangent inverse is equal to the measure of angle A. The sine inverse is equal to the measure. Cosine inverse is equal to the measure. Okay, so again, when we use the inverse function, we're looking for the angle measure. Now here's how you're going to use inverse. I'd like you to get the calculator out that you're using, and I'm going to base it off of the TI-30X2S. Let me just Google that real fast so we have that to work from. So TI-30X2S. All right, so in this calculator, hopefully we can see it. We're going to right above sine, cosine, and tangent. And I'm looking right here. Oh no, what happened? There we go. Okay, so I'm looking right above sine. Notice there on the screen, this says sine inverse, right? So right above cosine, it says cosine inverse, and right above tangent, it says tangent inverse. So it's really easy to apply the inverse function. You're just going to hit the second button and then whatever you want. If you want sine inverse, you're going to hit second sine. Cosine inverse, second cosine. Tangent inverse, second tangent. Okay? And that's going to give you what it is that you need. Now, if you're using a different calculator, feel free to send me a picture of it, the name of it, an email, whatever the case may be, and I will happily show you how to do it if you're having trouble finding it. So we're going to go ahead right now and just find angle measures. They're saying let angle A and angle B be acute angles in two right triangles. Use a calculator to approximate the measures of angle A and angle B to the nearest tenth of a degree. Okay, so basically what we can think of in example A here is that there's some right triangle. This is angle A. Oops. This is angle A here. And they have done the opposite. So the sine of angle A is equal to the opposite over the hypotenuse. They've done that, and they get 0.76. So what we're going to do is do the inverse function to find the measurement. Now I'm going to write something out to start. It's not meant to confuse you, but it's supposed to justify the steps. So if I take the sine inverse of the left side of my function, my equation, and then I take the sine inverse of the right side of my equation, we know that what we do on one side of the equation, if we do the same thing on the other, it's balanced, so it's an equivalent equation. Well, what happens is that this sine inverse and sine cancel one another out. And then over here, that gives me what A is equal to. So in my calculator, I put sine inverse of 0.76. So try that with me, please. Sine inverse of 0.76. We are going to get rounded to the nearest tenth of a degree. That means that the measure of angle A is about 49.5 degrees. Okay? All right, for the remaining ones, I'm not going to set it up that way. I'm just going to do the inverse function. So this one here is going to be cosine inverse of 0.17. I did it here just so you could understand why you put those numbers in where they do, but the inverse is always going to take on whatever that value is. Okay, so the cosine inverse of 0.17 is going to give me the measure of angle B equals 80.2. And that's a degree value. Okay. All right. Now, just so you can get an idea that we're on the right track, I'm going to go back to that big chart. So let's look for an 80-degree angle and see what the what we get. Okay. So if I go over here and I go to an 80-degree angle all the way down on this list, cosine is this middle column. Okay. Whoa. So if I go down to 80 degrees, I get, for an 80-degree angle, it's 0.1736. If we look back at what we just saw, an 80.2 degrees would be specifically just 0.17, which we're in the right ballpark. We're doing a good job. Okay, you don't need to cross-reference anything with that chart, but I just wanted to show you that things, how maybe they relate to one another. All right, so again, Here I'm going to go through and I'm just going to do the tangent inverse of 0.95. And if I put that in my calculator, it's 43.5 degrees. So I would say the measure of angle A is 43.5 degrees. All right, let's try this one. This is going to be the sine inverse of 0.23. The sine inverse of 0.23 is 13.3. So the measure of angle A is 13.3 degrees. Just to make, now that we've done a few, I'm going to go back to the setup again, this portion as to what we're really doing. So again, in example E, you can jump right to this, like the process, it's just the cosine inverse. But again, we're taking the cosine inverse of the left side, and if we do that on the left side, we have to do that on the right side. These end up canceling out. Cosine inverse and cosine, they cancel one another out. So that's where I'm just left with angle A is equal to the cosine inverse of 0.12, 0.12. So we say the measure of angle A, when I put in the cosine inverse of 0.12, oops, we get 83.1. So the measure of angle A equals 83.1 degrees. All right, we have one more left, and again, I'll just set it up here because we haven't done a tangent setup yet. For this one, I would take the tangent inverse of the left side, which is the tangent of A, and then I would have to do the same thing on the right side. The tangent inverse of 0.67. These cancel, so I'm left with angle A. So again, you do not have to show that step. I wanted to for a sine, cosine, and tangent, even though they're all the same, just so you get an idea of why you replace what's in the parentheses with the decimal value that they gave us. All right, so I find that the measure of angle A is equal to 33.8, and that's degrees. So what we did is, again, they gave us what the ratio is. What they're doing here is they're giving us a right triangles ratio for any of these triangles. They're giving us, if I take D for instance, that from angle A, the ratio of my opposite over my hypotenuse is 0.23. I don't know what those numbers are, I just know what they simplify out to be. So with that being the ratio, we can work backwards and say, well, this angle must be 13.3 degrees. Okay, in the next lesson we'll apply it to some things, and then we're done with lesson 7.6 and we'll do some practice. Good work, guys.